Okay, we are on number 10, where you're really just taking a function and working through it and seeing what needs to go and all that good stuff. Okay, so find all real zeros and their multiplicities, factor the function of the real numbers. The very first thing that you're going to do is go to your calculator and type in y equals x to the fourth plus 3x squared plus 10x plus 6. Zoom 6 it so you can take a look at it, get your zeros off of the table, and what you'll see is at your -1, your graph actually like touches and turns. And remember, when it touches and turns, it's going to be an even multiplicity. If it goes straight through, it's an odd multiplicity, actually 1. And then when it does that weird bendy, that's a terrible bendy thing, but you know what I mean. It does that where it flattens it out. It's going to be an odd multiplicity, usually 3 or 5. All right, the very first thing that you see is it is a -1. So we are actually going to use synthetic division and the -1. So write your coefficients. I need a 1 for my x to the fourth. I need a 0 as my placeholder for x cubed. I get a 3x squared, a 10x, and a 6. And remember, you bring the first number down, straight down there, and then you are going to multiply diagonally and write that number up here, so -1. And then you are going to add straight down your column. So then I am doing 0 plus a -1 gives me a -1. I multiply -1 times -1, I get a +1. Add, I get a 4. Multiply, I'm going to get a -4. Add, I'm going to get a 6. And multiply, I get a -6, and then I get a 0, and then in honor of Z, there you go. So anybody who has Zuccharo, there's your smiley face. And then it's exactly what I should get, because we found out that from our graph, -1 was a factor. Because it touches and turns at -1, I'm going to synthetically divide again. So then I have, bring your 1 down. -1 times 1 is a -1. Add those two, I get a -2. Then I multiply those two, I get a +2. And then I add those and I get a 6. I multiply, I get a -6. And hey, look at that, I get a 0 again. So your real zeros are, and here's the thing, you kind of need to do all of it together. This top row, whoops, yeah, no, there we go. This top row is x to the fourth, x to the third. This is going to be x squared. So this is going to be x squared minus 2x plus 6 equals a 0. Okay, now ultimately, I would love it if I had two numbers that when I multiplied them, I get a +6, and when I add them, I get a -2. I don't, so I'm going to use a quadratic formula. So x equals the opposite of -2, so I'm just going to write my +2 there, plus or minus the square root of, when I square it, a -2 squared is going to be a 4, minus a 4 times a 1 times a 6, all over a 2 times a 1. So 2 plus or minus the square root of, I get a -20 underneath there. All right, and that's over a 2. Guys, your -20 can factor out into I'm going to write it just above it in red, a -4 times a 5. You can take the square root of your -4, so you get 2 plus or minus 2i radical 5 all over 2. And then each one is, oops, goodness gracious. Each one has a factor of 2. Oh, good grief. There we go. 2, 2, 2. So those are all going to reduce. And so you get two non-real solutions. A 1 plus an I radical 5 and a 1 minus an I radical 5. So those are non-real solutions. So when I ask for the real zeros for part A, okay, I'm going to go back up. We'll put it in blue. For part A, right, your x equals a -1 is the only real zero that you've got, and it is a multiplicity of 2, okay, because it worked twice. When it says factor over the real numbers, here's what ends up happening. X equals a -1, so x plus 1 is a factor, but it's twice, right? And then you had your x squared plus 2x plus 6 left over. Okay, and so factored, it would be x plus 1 quantity squared times x squared plus 2x plus 6. That's all it means, is when you factor it over the real numbers, is you factor it down to the most basic that you can without getting into your imaginary. We'll finish B too because we already factored that. So let me shrink a little bit though. There we go. That'll work. Whoop. Didn't want to shrink all of that, but we're shrinking all of it now. Okay. And then if you go to part B, it says find all the non-real zeros and their multiplicities. Well, that's what we just found. I actually found it when I was working on part A. But then ultimately what it means is x equals a 1 plus an I radical 5, and x equals a 1 minus an I radical 5. And so what I'm going to do is really subtract all of this junk, right? So x minus this junk here equals 0, and x minus this junk here, 1 minus I radical 5, equals a 0. And so when I factor it over the complex numbers, it really just is, okay, the real stuff that I had, let me make it smaller again, sorry. Whoops! I did not realize all of that was going to go, but that's all right. The real factors, x plus 1 quantity squared, and then I'm going to have an x minus a 1 plus I radical 5, and times an x minus a 1 minus I radical 5. Okay? So nothing crazy, you're just doing your calculator to get to a 0, then some synthetic division, then some quadratic formula. I'll talk about C and D in the next video.